afternoon. I'm David Wilco, and I have the pleasure of introducing Tim Searchinger. Tim is a member of our faculty in the Woodrow Wilson School, as well as a senior fellow at the World Resources Institute. And this is a particularly fun introduction for me in that I've known Tim for almost 30 years now, because he was a senior attorney at the Environmental Defense Fund in the 1990s, time that I worked there as well. And at EDF, Tim was really a standout in terms of his ability to combine scholarly research and litigation, and both those to very high standard, on the general topic of agricultural policy and wetlands protection in the United States. So at that time, Tim was heavily involved in a variety of projects, but including the restoration of the Everglades, which has been a long, contentious, and very expensive public policy issue. Under the George H.W. Bush administration, there was an effort to roll back protection for wetlands under the Clean Water Act, and Tim took a lead role nationally in preventing the administration from rolling back wetlands protection. He also turned a lot of his attention to the issue of developing incentive programs under the Farm Bill that would get farmers to restore habitat for wildlife. And the Farm Bill is often described as the most important piece of the legislation that no one knows about. But in fact, it really determines the direction of agricultural policy and land use across vast portions of the United States for long periods of time. And Tim was highly successful in developing a number of incentive programs, getting them into the legislation, which has resulted in the restoration of literally millions of acres of wildlife habitat. Tim joined our faculty in 2007, and shortly after coming here, he turned his sights on the issue of biofuels, and in particular, corn-based ethanol, and published a very influential and very controversial paper that showed in quite a rigorous and quantitative way that corn-based ethanol did not help to address the problem of climate change, which generated justifiably a great deal of attention from policymakers and earned him the eternal wrath of corn growers, much to his credit. He has continued to study issues related to agricultural policy and land use, both nationally and increasingly globally, and focuses much of his work on that near existential question of how do we feed a future world of 10 billion people without trashing the planet. And today he's going to tell us about some of his most recent research related to that critical question, in particular focusing on an important study that he led that has just appeared in Nature that addresses the issue of land use and climate change. And it's a pleasure to bring Tim Searchinger in for a C-PREE set.
Thank you, David. Thank you very much. This study was about 7 years in the making. And what you see here is a map of the globe, and roughly half of all the world's vegetated land is used for agriculture. And that agriculture is responsible for somewhere between a quarter and a third of all the carbon dioxide in the atmosphere that people have added, because vegetation and soils contain a great deal of carbon, and when you convert them to agriculture, you lose virtually all of the carbon in the vegetation and maybe a quarter of the carbon in the top layers of the soils. And we need to produce a lot more food, and we're likely to convert more land, and this raises an immediate issue of how do you do that and also solve climate change. So the summary, I'm going to get deeply, deeply into the weeds, but here's the précis of what I'm going to argue to you. which is that in order to feed the world and store more carbon, given the fact that we have a fixed area of land, you need to make more efficient use of land. It's all about efficiency. I'm going to argue that all the methods that researchers and policymakers are using to evaluate land use change don't do that. In fact, they tend to treat land as though it were a free asset. And that has led to enormous policy distortions. And what we do in this paper is we provide a new method for doing that calculation, which has a lot of important policy implications. So that's the thumbnail sketch of this paper. But I'm going to get deeply into the weeds of these methods because it's precisely in the weeds when you're kind of doing math, you make conceptual errors. And I'm going to have to do that to explain. Okay, so let's start off with the fact that most people project we need more than 50% more food by 2050 to feed a larger population that can afford more resource-intensive food like meat. And among those meats are large increases in ruminant meats. Ruminants are things that graze, cattle, sheep, and goats. They are particularly efficient. They use pasture, which is 2/3 of the world's agricultural land, an area almost equal to all the world's forests. And we're going to get even larger increases in demand for those. And virtually everybody who models this, which of course is based on lots of assumptions of future yield growth, estimates that we're going to increase, that we're going to increase agricultural land use area by 2050. And this is one modeling study, and there are other studies that have even 1 billion hectares of agricultural demand to meet growth. I came out with a paper, a big report, where we estimate 600 million hectares. But even if you didn't need more land, land always has an opportunity cost. Now, these are complicated graphics I don't intend for you to study, but the key point is that, particularly if you want to reach 1.5 degrees, but even 2 degrees, which is the climate stabilization path, all of the pathways people typically focus on assume or require that we essentially eliminate land use change within a few years. And in fact, we start restoring forests. So this brown stuff here is restoring forests. The yellow stuff here is bioenergy that would combine with carbon capture and storage. I won't go into that, but you need land in order to do that. And the point is that even though almost all projections are that we need to increase agricultural land, all the solutions require that we decrease agricultural land, even while meeting food demands. And the point is that even if the yields were much higher, every hectare of additional land that we don't need is a hectare we can reforest or otherwise use to store carbon. So part of the message is that land always has an opportunity cost. And here's the thing, again. If we need more food and more carbon storage, but we have fixed land area, we can't do that. We can't do all of those unless we make more efficient use of land. Okay, so what is an efficiency gain? Well, obviously, this is an easy example, right? So if you're growing corn badly and you can grow corn better, that's an efficiency gain, right? You get more corn per hectare. And if you've got bad growing forest and you can turn that into really rich forest that will store more carbon, that's an efficiency gain. But what about if you convert agricultural land, geez, this is a terrible pointer, to forest? Well, it kind of makes sense that if you're growing agricultural land, growing corn really well, just converting it to forest isn't a good idea. That's not an efficiency gain if the forest is bad. Now, similarly, if you have a really good forest, converting that to agricultural land can't be a particularly good idea. But the point is that we need to figure out when is making a land use change good? And it's a question of efficiency. In a world that needs both more corn and more forest, we want land to grow corn well when it's growing corn. We want land to grow forest well when it's growing forest. But you don't want to trade off one that's doing well, one for the other. But a typical analysis, just so you know, would assume that this is good, right? More forest stores more carbon, that's good, regardless of the cost. So efficiency is intimately tied to opportunity cost. It means that when you change a use of land from one use to another, you get a benefit, but the cost is what you're not using it for. And so you always have to, if you want to evaluate efficiency, you have to factor in the opportunity cost. The opportunity cost of using land for forest is not growing food. The opportunity cost of producing food is not using forest. You always have to count it. Okay, so now I'm going to start getting into the weeds. And here I'm going to give you 4 examples of the way both researchers and policymakers evaluate land use change that, in effect, ignore completely or grossly underestimate opportunity cost. So a typical analysis that is used is something called a life cycle analysis. And in a life cycle analysis, you add up all the costs of doing something. So a life cycle analysis for driving would include not just the carbon emitted from driving a car, but also the carbon emitted from making the car and disposing of the car. And for food, you add up all the emissions involved in producing the food. Most life cycle analyses for food don't even factor in land use at all from a carbon standpoint. They might report the land use, but has no count, no cost. Some factor it in this way, including by the Food and Agriculture Organization. And here's how it works. They basically, and I'll give you the shortcut, they treat all existing agricultural land as though it has no opportunity cost. So here's how it works mathematically. Come on, where is this thing? Where's the pointer? Oh, wait. Oh, here it is. Yeah, okay. So imagine you have all of this agricultural land basically in brown in Brazil. And in a given year, you produce more soybeans and you deforest a few more hectares of land, a few more acres of land. And the way they count the emissions, the land use cost for food then is to say the land use change equals the emissions from that change divided by the food produced on all of the agricultural land in Brazil, or all of the soybeans, or in this case it might be a big pile of corn. So what that means is you're saying we're only counting the additional conversion that year, which could be 0. It could be 1 hectare, it could be 100 hectares. We're counting the carbon loss from converting that land, but we're dividing it by the entire amount of corn or soybeans produced in Brazil. So it's a very small number. And in fact, let's say you were expanding soybeans in Brazil that year, but you were contracting corn areas, so there wasn't any land use change. Your land use cost would be 0. In the US, where we're not having net expansion of agricultural land, the land use cost is 0. So this life cycle calculation would say if you're in Europe and you buy your soybeans from the US, the land use cost is 0. If you buy it from Brazil, it's small. It's just this amount of conversion that occurred that year divided by the total production. So it's a very, very small cost. There are many analyses of reforestation potential that say, oh, we can sequester a lot of carbon by reforesting land. And these include, for those of you who are old enough, you may remember the report by Lord Stern, who was very influential and who came out and showed that we could solve climate change at a low cost in the UK about 15 years ago. And his report relied very heavily on reforestation. And that analysis, unfortunately, was done in this way. They basically said, what's the cost? What's the potential to reforest? It is the amount of carbon we can gain by reforesting each year. So it might be about 3 tons of carbon per hectare per year, times the price of carbon. Let's say it's $50 a ton. So if you get 3 tons of carbon per hectare per year, and it's $50 a ton, it's worth 150 bucks. And then where can we do it? Well, it depends basically on the rental value. If the rental value of the land is less than 150 bucks per ton, then it's worth doing it. Then we can do it. So wherever you could reforest land and it was, the carbon value was cheaper than the rental value, you would say that is part of our reforestation potential. And it turned out to be, depending on the estimate, hundreds of millions of hectares of land, huge amounts of carbon gain. What's the problem with that? Well, you need to know a little economics. So what determines the rental value of something? Scarcity. And it's the opportunity to do something some other way. So I'm only going to pay an amount of money to rent a piece of cropland here, an acre of cropland here, if I can't, for less money, clear another acre of cropland somewhere else and produce the same amount of food? So what that means is that the cost, the rental value, is actually lower the easier it is to clear more land, more forest, to produce more food. So they weren't measuring the cost of producing more food, the cost of reforesting land while producing the same amount of food and gaining forest. They were actually measuring the cost of reforesting 1 acre of land compared to clearing another acre of land somewhere else. So it had nothing to do, really, with the value of the real cost of feeding us and reforesting. In effect, it treated the carbon value of land as 0. Okay, here's another example. Now we get back to my favorite topic, biofuels. So this is a typical life cycle analysis for biofuels. And these life cycle analyses are the analyses used by researchers and governments to try to show why biofuels reduce greenhouse gas emissions. And what you do is you compare the emissions, let's say, from gasoline versus ethanol. And in the first column, you have the emissions of mining crude oil versus growing a crop. In this case, it's a grain. And the emissions are always higher to mine the crude oil, to grow the crop. Because mining, you know, the carbon emitted by mining oil is not very hard, right? The carbon we worry about is the carbon emitted by burning the oil, right? By burning the gasoline. Then refining is also pretty cheap from a carbon standpoint for gasoline, much higher for ethanol. Then when you burn it, you actually emit the same amount of carbon from the tailpipe. And actually for ethanol, you also emit 50% more of that carbon when you turn a starch into ethanol. And if you counted all of that, you would actually show that you increase greenhouse gas emissions from ethanol. But what they do in these analyses is, I should have had this line here. They don't count this and they don't count this. This is the carbon that was in the corn or the wheat that turns into energy, right? This is the carbon released when you burn the ethanol, which basically grew from the carbon in the corn or the wheat. And they claim that's offset by the carbon that is taken up by the corn or the wheat when it grew, right? So it's neutral. The idea is that the fuel is free because the carbon you release by burning it is offset by the carbon released by growing the crop. And I can show lots of things about that, but here's the thing. It takes land to grow a crop. Where's the cost of the land? There's no cost of the land here. You assume that the land that you devote to producing the crop that absorbs that amount of carbon is free. So the assumption was, in the typical life cycle calculation, that land was free for biofuels. Okay, so I come along in 2007 and say, well, look, one way of counting that cost is by saying how much land has to be cleared to replace the food. And my paper showed that in my paper we'd use an economic model and it said, hey, by the way, that cancels out all the benefit because you've got to clear more land. Other people now come up with economic models and say, no, actually Searchinger is wrong because we think other things happen and actually we don't have to clear that much land to replace the food. Now what's actually going on in those models? Okay. So, and by the way, this is called indirect land use change. It's also called leakage. And people do the same analysis if you reforest land and say, well, what's the cost of replacing the food? It's a leakage analysis using an economic model. Okay, so let's figure out what's going on in those models. So here's the baseline. So the baseline condition is we're growing corn, let's say, on 2 hectares of land. And what happens to the carbon in the corn? Well, it gets emitted by livestock and people who eat it. I will show you a greenhouse gas emission. You are all emitting even as we speak. And so growing corn, even though it absorbs a lot of carbon, does not sequester carbon over time because we eat it. Now, an economic analysis does the following. It says, okay, what if we take 1 hectare of this corn land, and let's say we turn it into forest. Let's look at the analysis of forest. Then it says, well, how much land has to be converted to replace that food? Well, what happens is taking this land out of production increases the price of corn. And as a result of it increasing the price of corn, the model may estimate, and it's disputed, but it may estimate that other farmers, so the other farmers using this other land that's still in corn production, may use more fertilizer, do something, increase their production of corn on the same land. And that absorbs more carbon. And then also because the price goes up, some people eat less. And because they eat less, they emit less carbon. And then that means we have to replace less food, and when we replace food, yeah, we convert land and we release a lot of carbon from converting that land. But in some models, these play such a big role that this is pretty small. So the question is it a question? One question is it just one modeler versus another? Who's right? And what I want to present to you is the idea that this actually has nothing to do with efficiency. We shouldn't care, even if it were right. Why is that? Because what causes the greenhouse gas benefits here? So what the greenhouse gas benefits come from increasing the efficiency of this farmer's production. He grows more food. Let's say increasing the efficiency of consumption. I don't know if we call it efficiency, but we get a greenhouse gas benefit because people eat less. And you may laugh, I had a paper in Science in 2015 showing that the EPA's model that calculates greenhouse gas benefits, all of the gain came from the fact that people eat less. And who eats less? Of course, it's the poorest people in the world who eat less, not us. But if we want to count that as a greenhouse gas benefit, we say that's an efficiency gain. And these are efficiency gains that occur not on this land, but on other land and by other people at others' expense. Right? Their expense is they eat less. Who's paying the farmer to produce more food? Global food producers who pay more for food. And how do we know that it has nothing to do with efficiency? The answer is we get the same benefit, quote, benefit. These things would be exactly the same if we took this land out of production and just left it bare. So leaving it bare is the most inefficient use you can imagine. And yet we'd get the same, quote, benefit in increasing the efficiency of consumption and production by others. Everyone follow that? Okay, so why is that a bad idea? Well, here's the way to think about it. I have a new climate strategy for driving. My strategy is everyone who drives has to drive a luxury Hummer. And imagine this is like a stretch limousine, $500,000 a year, 2 miles to the gallon. So I say, no, you can't. You Searchinger, who lives in Tacoma Park, very liberal, everyone drives a Prius. You cannot drive a Prius. If you want to drive, you've got to drive a luxury Hummer. You say, what? Going from 60 miles a gallon to 2 miles a gallon? How could that be good? I have an economic model. In my economic model, it says driving is going to become so expensive that lots of people won't be able to drive at all. They're just going to stay home. And that gives greenhouse gas benefits. And other people will shift to mass transit instead of driving. And that will give greenhouse gas benefits. So this is a great greenhouse gas strategy. And in fact, this is probably true. It would certainly be true if you said, no, you have to drive a tank, right? $1 million a year. Does that mean that's a good greenhouse gas strategy? No. Why? Because the alternative is we use taxes and subsidies. We tax gasoline. We subsidize mass transit. We use the same economic signal to induce people to drive less and take more mass transit. But for the people who are still going to drive, we want them to drive an efficient car. Now, how do we know that you could do that? Because that's, in fact, what Europe does, right? Taxes gasoline, subsidizes mass transit, and requires that the people who drive more efficiently. We want all three. So using this type of economic signal to cause other people to do efficient things is a very bad idea. Okay, so here's the key. Now the question then becomes, how do it? Now, here's the problem we have. The problem we have is that, look, I can tell you, we all know that when you shift from doing a Prius to using a Hummer, your driving is less efficient. How do you know when you go from producing corn to producing forest to producing kumquats, is that more efficient or not? That's the challenge we have. So that's what we came up with after a mere 7 years, a method for doing that calculation. And so I'm going to get again into the weeds, so I want to tell you the really simple, the simple concept, because the concept is pretty simple. What is the cost from a greenhouse gas standpoint of consuming a food? It's all the carbon that was emitted to produce the food. And that includes the lost carbon storage. That includes the loss of carbon in forests. And then what's the benefit of producing food? The benefit is the greenhouse gases you save from not having to produce that food somewhere else. That's the basic concept. And then there's another really important concept, which is we need, even though we care about both the efficiency of consumption and the efficiency of production, we need to pursue them through separate policies. In other words, we don't want to do the SUV example. And here's an example why. I'm going to go through in the fact that consuming beef is really inefficient. And we'd much rather have people consume veggie burgers. That's the Impossible Burger. It's a veggie burger. But does that mean that the way to do it is to take an efficient grazer of beef and say, we're going to take your hectare of beef out of production? What would we do if we just paid somebody not to produce beef efficiently on their hectare of land? Well, most of the beef would be produced somewhere else, probably less efficiently. And in fact, it would probably be very inequitable because some other farmers would shift from producing food consumed by poor people to producing beef consumed by rich people. So it's a really bad strategy to try to deal with the efficiency of consumption by trying to discourage efficient production. This is just a rephrase of the SUV example. We need policies to do them separately. Okay, so let's think about it. What are the benefits? What are the carbon benefits of producing? Well, there are some benefits that you can measure directly in carbon terms, right? So if you grow a forest, it's the carbon sequestered by growing the forest. If you produce a biofuel, it's the fossil fuels displaced from the crops that turned into the biofuel. Okay, so the first thing we do in counting carbon benefits is we count that. And the carbon change can be a loss or a benefit, right? If you grow a forest, that's a benefit. If you cut down a forest, it's a cost. If you sequester more carbon in your agricultural soil, that's a benefit. If you lose carbon in your agricultural soil, that's a cost. And the displacement of biofuels, we count that. Okay, that's the easy part, right? Everyone can do that. The question is, what's the cost of food? What's the opportunity cost of food? So here's a really simple way. Well, you could say, well, look, if you're producing food and you could stop producing food and sequester carbon, the opportunity cost is simply the carbon that you could sequester on that same land, right? That's a really easy way of doing it. But the problem is that land produces different amounts of food. So we need to factor that in some way, right? If you're losing 10 tons of carbon per hectare, 10 tons of corn per hectare, that's got to be worth more than losing 5 tons of corn per hectare. And it's not just that. Now, how the hell, sometimes you're producing corn, sometimes bananas, sometimes milk, sometimes forest, sometimes bioenergy, sometimes beef. How do we decide how much of one is worth? I mean, how much corn is worth how much beef is worth how much forest? That's the challenge. Well, there's a pretty simple, and here's the efficiency point again. If we're producing corn well, we don't want it to produce forest badly, but we might want, if you're producing forest badly, we might want to turn, or corn badly, where's the point? Okay, corn badly, we might want to turn it into forest. So we want to go this way, not that way, right? Okay, so here's the simple way of doing it, conceptually. What's the benefit of something? What's the value of something? It's the cost. So if you've got, if a taxi costs 20 bucks and a coat costs 100 bucks, how many taxi rides are worth one coat? 5. So if we can estimate the cost of producing each food from a carbon standpoint, we can then compare the cost of one versus the other. So what we did was we said, how much carbon have we lost to produce each food? Now that's complicated because we have to figure out which lands are producing corn, which lands are producing bananas, which lands are producing beef. We have to count the carbon that was lost from those lands. And that's not easy because they're producing corn. We have to estimate what the forest carbon was or the other carbon was before they were producing corn. But we did that in ways we can go into, and we estimate the carbon that we've lost to produce each food. So the assumption is that if we didn't produce that food in one place, we'd have to replace it at the global average cost. That's the assumption. And so that produces something called the carbon opportunity cost. That's the number, the amount of carbon we lose to produce a kilogram of each food. And so there it is. So imagine if you produce 5 tons, 5,000 kilograms of corn on a hectare, you multiply that by the average loss of carbon to produce each kilogram of corn, and that tells you how beneficial it is on that hectare of land to produce corn. 10,500 kilograms, a number. That's basically 10 tons, 10.5 tons. Okay, what about production emissions? Well, the costs of producing food aren't simply the carbon loss from storage. There's all kinds of these greenhouse gases that come up. Enteric methane, rice methane, nitrous oxide from, where the hell is this? I've lost this again. Nitrous oxide from manure, et cetera, fertilizer, energy. We have to count that too. So we estimated the amount of production emissions to produce each food in the world. This is why it took 7 years. And however, if you think about this, what's the benefit? How do we factor that in for a food? The point is that if you produce food with fewer greenhouse gas emissions, that's a benefit. If you produce food with more greenhouse gas, more methane, that's a cost. So for any particular hectare of land, if you're really efficient, we count that as a benefit. If you produce it for fewer emissions per kilogram of food, less methane, we count that. More methane, that's a cost. So in total, there are 4 factors: the change in carbon on the land, displacement displacement of gasoline from bioenergy, gasoline emissions, the food value, the food carbon cost, and the difference in production emissions. Okay, so now we show you. Now, the last thing I'll say is that's the benefit of production. What are the costs of consumption? That's easy. That's simply the amount that you lose, right? That's all the production emissions per kilogram and all the average carbon that you lose per kilogram of a crop. So that's easy. But again, remember, calculating them separately. Okay, so here's some results. I'll come back to this, factoring in time. Here's some results. Well, actually, I think I have to go into time. So time matters. So remember, you clear a forest, that's a one-time loss of carbon. But in theory, you could produce the food forever. So if you didn't care about time, if we didn't care about when we solve climate change, the cost would be very small, right? You could produce biofuels for 1,000 years, whatever. So I'm not going to get into that, but most people think we have to reduce greenhouse gases a lot by 2050, so it matters that you're doing it in the short term. So we built in a discount rate, the timing, et cetera, et cetera. We use a 4% discount rate in our central scenario. Okay. So here's some results. So you can express it per the carbon cost per kilogram of fresh weight or per calorie. So let me focus on per calorie. So corn, the cost is 0.82 grams of CO2 per calorie. Now, that's who knows what the hell that number is. But what's interesting is that's about the same number as wheat. Now, why is that interesting? because wheat yields are about half those of corn. So why shouldn't wheat be twice as expensive as corn? And the answer is we use much poorer quality land to grow wheat. So it turns out that even though the yield is half, we only lose about half as much carbon per hectare. Meanwhile, soybeans, we use very similar land to corn, but soybean yields are about half the yields of corn. So that we lose the same amount, we only get half as many kilograms of soybeans, which means each kilogram of soybean costs more, which also means each farmer who produces a kilogram of soybeans is producing more benefit because it saves more carbon from having to be lost to produce those soybeans somewhere else. Everyone follow that? Right? The cost of something, if it's something more expensive, it costs you more, but it's also more valuable to produce it. But here's then when you begin looking at this. Look at beef. It's 100 times the cost of producing corn per calorie. And it's 10 times, more than 10 times the cost of producing pork. So you begin to see some interesting numbers. Okay, so now when we did this for 56 outputs, let me translate this into some interesting examples. So in Brazil, they've cleared almost 200 million hectares of land for grazing. How much is 200? That's a quarter of the continental US. And most of that land is badly grazed. And people say, hey, look, the solution, therefore, is to take that land out of production and produce something else, like soybeans or sugarcane. Yeah, but we need the beef. So we looked at what would happen. What's the benefit? What's the carbon benefit of producing beef in Brazil in terms of the cost that you would lose? How much carbon would you lose somewhere else if you didn't produce it in Brazil? And per hectare, it actually turns out to be not as low as people think. It's this number. And if you graze, so if you graze badly, it's this number. If you graze well with rotations and fertilizer, you can easily get up to this number, which is almost 20 tons of CO2 per hectare per year benefit. And it turns out soybeans, which are really efficient in Brazil, generate less carbon benefit. In other words, if you have a hectare of land in Brazil and you have a choice, even though you're grazing it badly, between grazing it well and turning it into soybeans, the world is better off if you graze it well. Because the cost of replacing that beef somewhere else is higher than the cost of replacing the soybeans. What about sugarcane ethanol? Dramatically, dramatically better. We're much better off using that land to graze well than to turn it into sugarcane ethanol. What about reforesting? Well, it turns out that it's actually better off to graze it well than to reforest it. But there's another example. So this is the Atlantic coastal rainforest where you have highly steeply sloped land. And there, you really can't graze it well because it's too steep. But if you reforest it, that's better. So this tells us that basically, if you can't graze it well, reforest it. If you can graze it well, graze it well. What about diets? So everyone, you probably are well familiar. For decades, people have been saying, hey, yeah, consuming meat is bad for the climate, bad for the resources. Beef in particular. They grossly underestimate how bad it is by our calculation. The interesting number here is this number. Almost 9 tons of carbon per person per year is the greenhouse cost of the average European's diet when you factor in essentially the land use opportunity costs of carbon. The carbon that you could store on that land if you weren't using it to produce food. Why is that such a significant number? That is the typical number that is estimated as the greenhouse cost of the average European's consumption of everything else. All the energy, everything else. All the food, in fact, typically. So if you count the land use costs the way we do, the European's diet is a bigger deal than anything else the European consumes. And similarly, if they just got rid of beef and dairy, you'd cut those emissions by more than half. What about Iowa cropland? Well, just intuitively, you should think if Iowa cropland, now, and this pains me. I spent years trying to restore Iowa cropland, little pieces of it to wetlands and floodplains and things like that. But in a world that needs more corn, it would be hard to imagine that taking the world's best corn land out of production is an efficient strategy, right? So sure enough, by our calculation, producing corn and soybeans is dramatically better than producing ethanol from the corn. And in fact, interestingly, from the ethanol from the corn, 80% of the benefit comes not from the ethanol, but from the feed byproduct. So when you produce ethanol, about a third of the food comes back as a feed. And that actually is much more valuable than the ethanol. And what about cellulosic ethanol? Well, you would actually, really optimistic estimates say you might get this much cellulosic grass produced per hectare. And it's still much worse than just producing corn and soybeans. Now, if you turn that around and look at it as consumption, what is the benefit of electricity using solar, even in Central Europe, versus ethanol or biodiesel versus gasoline? And basically, for ethanol is about twice as bad as gasoline or diesel. Soybean biodiesel is 3 times as bad, and solar energy is a fraction. So even using today's batteries, if you use solar energy to produce your electricity for an electric car, it's like 8% of the emissions when you factor in the land use costs.
Okay, clarification question. So when you're comparing the benefit of growing corn in Iowa versus a more marginal land, you're comparing that to like the global average efficiency of growing corn.
That's right. If you had to replace it, the global average efficiency. Right. That's right.
I'm sure this would be effectively a little more complicated, but conceptually, wouldn't you want to really look at the marginal?
Okay. So you're right. You'd want to look at you might want to look at the marginal cost. And the problem is we can't really estimate the marginal cost. And I'll come back to that because that's a really important point. Okay. It also turns out, to my disappointment, that in almost every case, using more inputs to intensify production is better than not using the inputs. So we looked at, for example, upland rice versus flooded rice. You get much higher yields for flooded rice versus upland rice. And even though you get a lot more methane, you're much better off producing the flooded rice. And actually, unless you can find a way to get your organic yields up at the same as conventional yields, from a greenhouse gas standpoint, unfortunately, the conventional is better. Now, there's a lot of debates about what yields you can achieve with organic, and you can achieve high yields, but if you don't, it's a problem. Okay. So first of all, what are the uses of this? So one point I need to make is that we don't factor in biodiversity, right? So there are plenty of times when you might want to take land out of production because it's important for biodiversity. And similarly, so that's just another factor that you have to factor in separately, and it's important. My view is that our index measure is a necessary but not sufficient condition for when you would deliberately make a land use change for carbon purposes. Because what we're measuring is, are you increasing the capacity of global land to store carbon while meeting food needs? And if you're decreasing that capacity, that cannot be part of the solution to climate change. Even if there were these indirect effects, the SUV example, even if it were the case that there were these rebound effects, it just still, if you're making less efficient use of land, that can't be the solution. Now, the other thing, here we get into this issue. So does that mean that the economic models, if you could do them, would have no value? Well, we'd want to know what they call them the rebound effects, right? So when you use a more efficient car, do you drive more and therefore lose some of the benefit of doing that? Or if you made producing beef more efficient, would that lower the costs and have people eat more beef? So there are reasons we care about that, reasons we care about those rebound effects. But what we do at least is give you a benchmark for evaluating the costs. So in other words, if the cost of replacing corn is the same as the average cost of producing corn globally, that we'll give you the number. We give you a benchmark. Now, here's why that's really important. So for California, using their economic model, they estimate that corn ethanol has an indirect land use change of 20 grams of CO2 per megajoule of fuel. Gasoline's about 85, 90. So the land use cost is low for them. By our calculation, the average cost is 200. If they had to replace the corn at the average cost, it would be 200. So they are 1/10 of our cost. And in effect, when you translate that cost into a land use cost, they're basically saying that a hectare of land, the most productive hectare of land in the world, Iowa corn, is only worth about 2/3 of a ton of carbon per hectare per year. Now, if you know those numbers, you just let the forest come back, it's going to be worth 3 tons. They're basically saying, we're going to count really, really, really productive farmland as having this tiny opportunity cost of only essentially 2/3 of a ton of carbon per hectare per year storage. We cannot solve climate change if we value our really good land at only 2/3 of a ton. Now, why do they do that? Well, it turns out that these economic models require, I'm running out of time, so I'll just be real quick, hundreds and hundreds of parameters that nobody knows. And we can come back into that. So you can kind of come up with any number you want running those economic models. But here, let me give you one more, and this will almost end it here. So here, I'll give you an understanding of how an economic model can give you such strange results. So the Globia model, which is run by IASA, was used in Europe to estimate the indirect land use change costs of biofuels. And it came up with a number in the teens for grain-based ethanol. Why is that? So here's one reason. The way the IASA model works is it estimates the cost of producing food everywhere in the world, on every square inch of land in the world. So if you reduce production on some existing land in Europe, it's going to say, where is the cheapest place to replace that somewhere else in the world? And that means they need to have an estimate of the cost of producing food everywhere in the world, which means they need to have an estimate of the yield of producing food everywhere in the world. But we can't do that very well. So they have really big areas that they evaluate. And these are the areas in Europe, and they're, tens of thousands of hectares per area. And within each of these cells, you have forest, you have cropland, and you have tiny little bits of marginal land that are neither forest nor cropland. And the way their model works is they assign all of that land the same yield. And because that land all has the same yield, but the land that isn't forest or cropland has no financial value, the model says that's where we're going to produce the food. Now, this is a huge problem with all of these kinds of global land use analyses, which is that areas that turn out to look good because of errors in your data are precisely the areas the model picks to say is where things are going to happen. And it's not because they're stupid, it's because how else do you do it? You can't evaluate the yields in every square inch of land. One of the benefits of our tool is that, and we took this in the form of a calculator you can use, is you use your information about your hectare of land. You say, how much corn are we going to produce on this land? How many kumquats? How much carbon are we going to store? And then we use our global, all of our analysis goes in to tell you the global cost. So using the global numbers that we do, you average out all of these errors. Okay, so here's the summary. So the carbon cost of producing a food is the loss of carbon to produce it. The benefit is also the carbon that you save somewhere else by not having to produce the food somewhere else. We generate a number that's actually very interesting because it's a comparative advantage. Let's say in Mali, you're bad at producing forest and you're bad at producing cotton. But you're better at producing cotton, than, relatively speaking, to the global average than forest, or vice versa. We'll tell you which has the comparative advantage. And here are some lessons. The lesson is efficiency in land use is critical, and to do that, we have to count the opportunity costs. The standard methods have essentially treated land as either free or extremely low cost, which means they're wrong. On my count, they're wrong. This is a huge number of policy and research papers that, at least according to us, are wrong. And that it's really important to segregate, to make different types of policies. To affect diets, we need policies to change people's diets, taxes on food, persuasion, not taking good land out of production. You have to segregate those two. People combine them. And then here's my last, hopefully my last paper. This is the paper I dream of making me famous, and I can go and pontificate around the world offering bromides, and everyone says, oh, yeah. So Aldo Leopold, as many of you have probably read, he wrote Sand County Almanac. And it's kind of the Bible of private land conservation in the US. And his call there is for creation of a land ethic. We should care about the environment, not just food, in the shortest of terms. And we need a land ethic. But we also need a land use efficiency ethic. In a world with 10 billion people, where we have to produce that food, we got to make more efficient use of land. And that's the bottom line for us. It's land use efficiency. We got to find the right way to do it. So thank you very much.
Thank you very much. Questions for Tim Searchinger?
So I hope, this is very complex, so I mean, boiling it down to this lecture, I already really appreciate everything you've done with this, but just trying to help wrap my mind around one of the key components, estimating the opportunity cost of different types of land use, and also the efficiency of producing one thing. A lot of efficiency opportunity cost comes from land, for example, grazing for cattle. That ends up going out of production after a few years because it's overgrazed. It becomes very poor agricultural land. So you have land that is no longer a carbon sink, and you have land that's no longer being used efficiency for agriculture. If I understand correctly, is that something that's incorporated into these analyses, that long-term loss of productive agricultural land?
Well, we actually don't have a lot of, that's a complicated question. So there is a lot of land that's abandoned for agriculture, while other land is clear. And that land tends to reforest over time, or regenerate its carbon over time. And so in a way, yes, factor all those changes in. We do, implicitly we're factoring in all of those changes. But the real cost is actually only a little bit of abandoned grazing land that has not reforested in Brazil, or has not regained some other kind of vegetation in Brazil. So most of it is still grazed. Almost all of it is still grazed to some extent. Some is abandoned and reforests, and we basically are counting that too. Yeah, so we're factoring that in. But it's in other words, the carbon cost. You subtract any cost that's been regained on the land that's been abandoned. So from a purely carbon standpoint, if you mucked up land and you abandon, then you count that becomes a carbon gain.
Another question around how you value the efficiency of forests, especially like different stages of the forest. So like an old growth forest, potentially the soil can be really good for deforestation anyway, but at that point that it reaches old growth stage, it's always sequestering a lot more additional carbon every year. So would that be something that would be prioritized as like land that could be converted to agricultural land, and you cut down that wood?
No, because if you cut down that forest, you have to count the loss of carbon on that forest right away. So you have a huge cost. So the calculator will calculate that, basically discount with a discounted flow. So that's actually hugely expensive, is to cut down good forest.
So you still prioritize old growth forest versus land that's maybe virgin forest that's still growing but doesn't have it.
Right. So if land is regrowing, then over time, it's actually kind of interesting, which is on a global average basis, using a 4% discount rate, it turns out the average forest, cutting down the average forest is roughly the same as allowing a forest to restore using a 4% discount rate. It was actually kind of surprising to us. But that's, of course, all the different types of forests and things like that.
opportunity cost is because of the cost of land, labor, fertilizer, etc. You're saying you should add the carbon sequestration potential as an additional factor. That might change. Like what the comparative advantages are?
Well, so most people, of course, aren't paying attention to carbon at all, right? So they're just deciding where is it cheaper or not cheaper. But in various ways, researchers and policymakers sometimes do pay attention to carbon. So we say we deliberately encourage you to convert your land to bioenergy or to forest or vice versa. And it's when you're doing that, you have to count the carbon costs. But the methods they're using really treat land either as free or as or they only modestly count the opportunity cost. And so when you do count the opportunity cost, you'll do things differently.
Different geographic pattern of where you actually should plant different crops. But you also then add like the cost of transporting like the crop where it's now being asked to be grown to where people actually consume it.
Well, we count the production emissions and not the transportation emissions, but transportation emissions for food are actually pretty low, with the rare exception of when you're like flying in asparagus and things like that. So unless you're flying food around, they're actually fairly low cost, particularly compared to the land use cost. The land use cost is the overwhelming cost. But that doesn't mean you basically say, well, look, we're going to massively change land. The whole point is this is really a tool when you're within a place, right? So you might say, well, look, we want to produce more food in efficient countries and less in inefficient countries, but that's not realistic. But in the inefficient countries, if you're deliberately making a decision, you want to make it more efficient within that country.
So in Iowa, you wouldn't get forest, you'd get prairie. And prairie has very deep roots and, it burns.
Mm-hmm.
I don't know, what's the sequestration of prairie compared to forest? And do you have to factor that in depending on where you're?
So we are not actually doing this comparison of saying if you took that land out of production and reforested it. We're not doing that. We're saying if you had to replace that corn at the global average cost. So just to be clear, we're not doing that. We're not saying, I mean, the alternative, the value of producing corn in Iowa, or the cost of producing, the value of producing corn in Iowa is not just that you save having to convert other prairie in Iowa, which doesn't exist. It's that you save converting land everywhere else in the world, right? So it's not that particular hectare. Now, if you were analyzing that particular hectare and saying, I'm going to take that hectare out of production and turn it into something else, then you compare it to the carbon value of something else. Today, actually, in Iowa, if you take land out of production, it will grow back its forest because you don't have fire across the landscape anymore. The reason Iowa was a prairie and not forest was because of fire. So this is a detail, but actually in that, if you really decided you wanted to do something else with land in Iowa, you could try to keep it as prairie, but you'd have to manage it as prairie. Otherwise, it would be forest. But we count, yes, when we counted the carbon costs, we counted the carbon costs of converting prairie, which are actually very high because they had huge amounts of soil carbon. So the cost in carbon of converting the prairie was extremely high.
Do you have any comparison forest versus, in terms of
It depends.
sequestration?
Yeah, I do. But it's less than a dense forest, but it's still a lot. And it depended. Actually, a lot of Iowa's wetland, too.
Yeah.
And we actually don't really factor in probably the magnitude of the carbon losses due to the wetlands, because nobody has for that. But yeah, you can calculate those numbers. One more on the
We'll make this the last
next
question,
question, yeah.
but then, Tim, if you don't mind
Sure.
staying behind for a few minutes, folks who have questions can come up after. Yes, please.
Why don't you use global average cost from the map? It looks like that would be heavily skewed upwards by production in tropical regions.
Yeah, so it's a good question. You could make an argument for using regional carbon opportunity costs, and the argument would be that if we don't actually have a lot of international trade, if you don't produce in one place here, you'll produce in another place here, let's say. And we're thinking we probably will produce some alternatives, which are kind of regional carbon opportunity costs. But the basic point is we use the global number because it gives you the global efficiency. And there is a lot of trade, and there is a lot of alternatives. And so we'll give you the global efficiency from this. Are you increasing global efficiency in changing your land from one use to another? And having said all of that, and our calculator allows you to play with these numbers and say, well, we're going to assume that it's only going to be half of the global efficiency or two. Here's the thing. It turns out it doesn't matter. So we did a lot of fluctuation in the numbers. So from a policy standpoint, it's who cares. So let's say your diet, let's say the diet number isn't equal to 100% of all Europe's other emissions. Let's say it's only equal to 50%. It's still a huge number, right? It still means you want to hold down beef consumption. And it turns out that treating land as free versus assigning it any kind of a reasonable estimate of its opportunity cost is night and day. So I actually don't care about the details. I mean, what I care about is getting people to do the opportunity cost calculation. And the reason we spent so many years developing this, I won't go into all the horrible details that held us up at various times, is because people want a number. And until we provided this, the only way to generate a number was to use an economic model, however fictitious. And these numbers all over the map, and they're good assumptions, whatever. And they want a number. So our theory is, look, we'll give them the ability to generate a number. And then they can play around with it all they want. But you tell me how valued. I mean, so let's say somebody says, okay, I don't think a hectare of really productive land in Iowa is worth even 3 tons of carbon. I think it's only worth 1.5 tons, which is incredibly dismissive of the value of this land. Even then, you still wouldn't do biofuels. Biofuels would be much worse than the alternative. It's just that you have to treat land as virtually free in order to do some of the things that we've been doing.
Tim, thank you so much. Appreciate it.